Aside from that kind of note, when you install new packages on NPM, you usually grab the latest unless there's a specific reason to choose like a different major version. That is, of course, when you like first, introduce it to the project. And I think from there on, all of like the bot automation that happens in the ecosystem, whether it's through Snyk or others, is something that is helpful to keep you on the latest version as needed.
Hi, you're listening to The Secure Developer. It's part of the DevSecOn community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out devsecon.com to join the community and find other great resources.
Hello, everyone, and welcome to another episode of The Secure Developer. And today we're going to be talking a little bit about supply chain security, but in the context of different ecosystems and different languages and the different considerations we need to make based on the ecosystems we're using. Joining me today are actually a couple of sneakers, each an expert in their own domain, own ecosystem themselves. So joining me is Liran Tal and Roy Ram from the DevRel and the product team, respectively. So why don't we jump into some intros first of all. Liran, first of all, welcome back to the Secure Developer podcast. This must be your, third, fourth time on the podcast?
Yeah, thanks for having me. It's always a pleasure having those conversations. So am I going to expect some trolling from you?
Well, when we talk about something as emotional as language choice and ecosystem choice, I think we're all lifers in our respective ecosystems. So I think it is one that will likely have a level of trolling in this episode, but we'll try and keep it to a minimum. But Liran, for those who are new to the podcast, tell us a little bit about yourself, a little bit about your background as well.
Yeah, sure. I lead the developer advocacy team here at Snyk, mostly helping us, developers be kind of more secure, but be aware of security, like the education perspective, the awareness of it, and so on. So it's a lot of fun just engaging with developers on those kind of, very early on security practices journey that they have, as well as hearing their feedback of, using the product, how it is, how it helps them, how we can improve it, and so on. My background is a developer with a poor life choice of using Node.js and JavaScript, I guess, compared to some other people here on the podcast, but I'm having fun with it.
Awesome. Amazing. Welcome again. And joining around here today is Roy. Now, Roy, you're first time to the podcast, right? Long-time listener, first-time caller. Well, welcome to the podcast. Tell us a little bit about yourself, what you do at Snyk, and also your background in tech as well.
Sure. So first of all, thank you for having me. And yeah, it's I'm a first timer, so take it easy on me with the trolling. I'm Roy. I'm part of the product team for Snyk Code, which is Snyk's SaaS solution. My main focus areas at Snyk Code is the language support, the framework support, understanding exactly what are the things that bring value to our users, both the security teams and the developers themselves. So I get to speak to a lot of security teams and a lot of developer teams, really trying to pinpoint what are the things that will give them the most value. In terms of my background, I come from cybersecurity, a good couple of years. Snyk is actually my first DevSec company, but I do definitely come from the cybersecurity field. If it's project management, if it's running a SOC team, if it's a bunch of different hats in the cybersecurity world.
My name's Simon Maple, and I'm going to be the host and moderator for this session. I'll be definitely trying to keep a cap on the trolling, but my background, 20 or so years in the Java domain, really. I've been a Java champion for a number of years as well. I actually probably cut my teeth on C as my first language, probably close to 30 years ago. And I did a lot of C and C++ at university, but really when I left uni and I joined IBM, actually, and Java was the core ecosystem that they'd invested in and they were moving into. So I'd really done a lot of my more commercial development in Java, and that's really been the last 20 years now of my life. So yeah, let's jump in and talk a little bit about, why don't we start with the differences really? We've already done a large amount of discussion back in February and March around supply chain security. And of course, some of the latest releases in and around our support of C++ at Snyk. We thought it would actually be a great opportunity to kind of like merge the two and say, well, for people who are thinking about securing their supply chain, and in particular, looking at their bill of materials, looking at the third-party dependencies that they're pulling in, what are the differences people need to really be cognizant of in terms of the ecosystems, the languages that they're using? Is there anything we need to be more aware of? Any approach changes that we need to make in our approach to being more secure? So why don't we start, Liran? Why don't you kick us off? Talk to us a little bit about, how you feel the differences, I guess, are. What are the core good and bad in and around the JavaScript and Node space, in and around kind of third-party security and third-party dependencies?
Yeah, I think so. When it comes to that, it's like the registry itself, the ecosystem. And that is kind of like, what is the profile of developers and maintainers, right? So I think JavaScript is probably one of those language ecosystems which are very fast moving, very easily adapted, very easily forked in terms of the open source project, getting like several revisions and suddenly there's like a fork to like a different ecosystem or like a community that tries to do something else with it. So I think understanding that is, first off, like a really important aspect, that this is like a less conservative community, right? Language ecosystem that's like less conservative. It's fast moving. The maintenance changes, very quickly. So aspects like what kind of packages you can find on the registry is, very different. How long are they maintained is also very different. A lot of like options around choosing dependencies too kind of differs based on that, because then you have to look at different properties of, what's the maintainer profile, when was, last committed change to a dependency and so on. So I think that kind of like profile of the developers and maintainers to a specific ecosystem, whether they're like, less conservative, more conservative, is like very important in understanding also how to approach managing dependencies and the spill of materials for that ecosystem.
Yeah, thank you. And same question to you, Roy.
Yeah, definitely. So I'll try to take it more on like the C and C++ side of things. So it's definitely, when thinking about just the amount of time that C and C++ has been around, the amount of changes it's undergone in like the 40 years or that it's been out, like just for the sake of, I wrote down just a couple of like dates and stuff just because it blew my mind. Like C and C++ came out in 85. Michael Jordan was named Rookie of the Year at that year. C came out in like 1972. It was like the first time women were able to run in the Boston Marathon. Like that's how long we're talking back. And to that extent, it means that essentially like you can do the same within this code base 10 different ways. And it means that you have so many different package managers and open source community is adding so much to it on a daily basis, because it's still being used for, in many cases, the most important code stack in an application. Generally, it's very old, but it's also potentially like the most important code stack. So I think the importance here is understanding exactly what you're introducing into the code. The fact that you very regularly embed open source libraries into your code, I think it's important to always be very aware of what you're introducing, potentially even more than some other languages, and really try to understand what it is you're introducing, how much can you rely on it, and really try to understand where it's coming from and make sure that it's secure.
Yeah. Yeah, that's amazing to think how old it really is, and 50 or so years.
That's great, because I suddenly feel just so much younger. So thank you for putting that in perspective. Like, great.
Well, many will really see Java as the C++ evolution, really. It's kind of like what C++ maybe should have been. It's maybe we should call it C++. But I think a lot of the things that kind of like C++, that Java adds on top, I guess, it tries to take a little bit more away from the developer in the sense of things like, your memory management and things like that. It tries to, help developers stay out of trouble. Like I remember when I was as a developer getting lost through pointers and addresses and all kinds of things like that, which is really, really hidden largely in the Java space. Of course, one of the other big core things around Java is the way it runs really as a compiled language, which kind of gets executed then in its own JDK and its own runtime. Significant differences there. I think it's obviously much more closer to C++ in the sense of the style of language, the typing of the language, that kind of thing, even the syntax of the language a lot of the time. It's going to be more similar to JavaScript in the way I feel its use of third-party libraries, particularly when we think about the way Maven or Maven Central or something like that is more akin to an NPM, I would guess. Let's dig a little bit deeper and kind of talk first of all about each of the languages use third-party libraries, which I think is one of the key things to us really understanding our inventory, our bill of materials, and ease of building our applications. So in Java, of course, we tend to use Maven, I would say mostly, Gradle as well as a very, very common tool to build and fetch dependencies. There are, of course, a number of others if using Ant, perhaps using Ivy, if we're going back a little bit, and some others as well. But Maven and Gradle are the main two that are used. And when we build using those, our POM XMLs and our Gradle build files, quite declarative in the sense of, the way we pull out dependencies that are used. We tend to kind of like pin in terms of versions. When we pull a dependency, when we use a dependency, we'll grab a dependency, a certain version. There are pros and cons to that, of course. And it can get a little bit complex, depending on which you use. So if you're using Maven, perhaps you're using parent POMs and you're using this module style system. If you're using Gradle, you could be using a DSL. It could actually be quite hard for systems to actually identify what you're actually pulling down purely on looking at the artifacts alone without building. But there are a number of things that we can kind of like do with that. Obviously, it's providing us with a listing there of the dependencies that you're using. So it allows us to more easily go and identify whether you're using vulnerabilities and where you're actually pulling them in from. So you both have kind of like the start of an inventory as well as a good idea as to how things are being built, how things are growing. I guess that's almost certainly more similar to the JavaScript space, right, Liran?
Yeah, I think there's definitely some parallels there, definitely within, third-party dependencies and how they're like bundled as nested dependencies. If we go back maybe a few years when we ran the state of open source security, we saw that there's like similarity between Java, JavaScript, and I think it was Ruby, which like most of the security vulnerabilities we find for projects is coming from transitive dependencies. So I think those kind of properties are definitely shared across the languages. I think when it comes again to like the registry itself and like managing some of those dependencies, there are definitely some differences, right? Like when you choose a dependency in Java, or I'd say even in C or C++, there's probably some foundation around it. There's probably some commercial entity around it. I guess, I don't know, Spring and things like that kind of makes sense. And I think that is part of why maybe a lot of the malicious packages, incidents that we've seen in ecosystems like JavaScript like makes kind of more sense in a way versus in Java, because also like the profile of the maintainer entity around some of those packages is like very different. In JavaScript, it's like very, indie developers who's just, not officially maybe having like a formal education and like, they're just like, some hackers somewhere and they code up, dependencies that end up, getting tens of millions, if not a billion of downloads, collectively from NPM. And it's probably wild to choose a dependency like that in the Java or C++ world, right? You go to the vendors more rather than to like the indie developers. That is one of like the primary characteristics of like maybe why malicious packages, trust issues and supply chain security issues kind of like make it more of a big deal on an open ecosystem like JavaScript rather than maybe some other ecosystems.
It is very interesting, actually, because I know if you just look at the sheer numbers of packages that have been registered, I don't know what NPM's at. I remember we did a blog a while back about the 1 millionth. It's probably way these days, probably like 3 million.
Yeah, I think we're at like 2.3, 2.4 about.
The other day, my youngest sneezed on my keyboard, a dog walked across it, and I looked up and I'd realized I'd literally just uploaded a JavaScript dependency to Maven, to NPM. And it's amazing how easy it is to do, right? When the 1 millionth package was raised, I saw someone on Twitter said, oh yeah, I did the 1 millionth. And I thought, how is that possible? Because it doesn't give you a number back and the website updates way too slow. And they replied back saying, I wrote a script that when it was about 40 or 50 below, that automatically uploaded 60 packages.
I remember that.
It's interesting because it gives that ability of being that fast moving organization. It is very, very quick. It is very, very easy. It really reduces the barrier to entry. But that does pose other problems, right? Things like typosquatting, things like malicious packages, like you say. Would you say it's a bigger issue on NPM than almost any other ecosystem, or is this?
It's a good question. I think we've seen campaigns where we had those malicious packages and typosquatting packages by like thousands of them across both NPM and Python. So over at PyPI. So probably Ruby as well. So I would say like NPM isn't the one to kind of like specifically call out of all packages. But if you compare that against, I think, more conservative like Java and C++, then definitely there's like a huge difference. Actually, just recently we were like chatting on Twitter and I was sharing that I was reviewing some like code on NPM and it actually featured no JavaScript, but actually a bash shell script. And I was sharing that, and someone on Twitter, Isaac, who's like the original maintainer founder of NPM. And he wrote, yeah, I actually do that a lot. And so we kind of like laughed about the fact that NPM is like just a general great, like, package manager and repositories that you could literally push like bash, scripts to it and use the NPM package manager to like manage those, like completely unrelated to JavaScript. That's a funny place.
And that's really interesting, because I think I would say definitely, Maven repositories are much more governed centrally, and they're, you almost like effectively need approvals and things like that to actually be able to push things up onto like a Maven Central or something like that, as well as update and things like that. So it's definitely slower, but you definitely see far, far fewer, I would say, issues in and around, whether it's typosquatting or whether it's even malicious code up into those spaces. So there's a definite difference in approach across the registry point of view. C++, Roy, how would you call out differences there?
Yeah, again, I think Liran touched on it a bit. It's a bit of a different ecosystem as well, where it might be a little more governed to an extent. So it might be a little tougher to do, but at the same time, I'm sure there are ways and smart people that are able to find the loopholes to get those malicious libraries into it. And again, like I said, I think just the fact I touched on it a bit earlier, I think just the fact that you, again, essentially embed that code into your code, it could also mean that some things might go through the cracks. And if you don't really look at your code and what are the things you're introducing, it's definitely potentially in some cases harder to actually notice, or things might go unnoticed as well. I think there are a couple of interesting conversations I had with some of the security teams where, again, going back to the fact that it's very old, we were talking to a company where they have 30-year-old code with 20-year-old vulnerabilities. There's a real struggle there, and kind of a tug of war between the security team and the developers, where the security team want them to fix everything, and the developers are saying, it's been here for 20 years. Nobody's actually done anything with it. Like, why do we even need to fix it? It's a real struggle, which might be a bit different than other languages where it's a bit more looked at a higher frequency. And in some cases, these vulnerabilities are taking a bit more seriously. But at the same time, it does explain the need to not only understand and be able to find them, but also be able to prioritize them and really focus on the things that are important for all sides, and to make sure that they're being fixed and addressed. That is something that I did come across in C and C++, less in other languages, where you really have those old code bases with very old vulnerabilities, where it's a real struggle to get the developers to really want to fix it and understand the importance of it.
And I think interestingly, when you look at something like C and C++, it's obviously older than open source, right? So when we think about the usage of libraries, third-party libraries within, your C and C++ applications, you're going to get a large variety of usage from them, right? Very often, people will just pull them in. Very often people may use a package manager, but tell us about your experiences in whether people are using package managers or whether people are just pulling in unmanaged libraries from third parties.
It really depends on the developers and what they're used to. I think some of the more old school ones would probably go towards embedding the open source libraries. You probably see that again a lot more in the older code. And again, C and C++ is continuously going through iteration and being improved on. So I'd say the more modern C and C++, you'd see package managers more often than embedded. That's what I've been noticing so far. Again, I don't know, maybe Liran, you or Simon, you've noticed something else, but that's definitely a trend that I'm seeing. So it's definitely more in the older code. Rarely see package managers. The newer code is the more frequent you would see that.
Somewhat a little bit as well, probably in the Java space. Unmanaged jars is something that kind of like still appears even. Liran, perhaps even in the JavaScript space. I think it's far more prevalent in the Java space. You hear developers using package managers like Conan perhaps, but I still see a lot of unmanaged jars, which I think really does. It provides almost like a different style of build that can actually allow developers kind of like more easily use code under the covers. I think any kind of like governance tooling and things like that your teams are going to want to use to kind of like identify, you're using a different strategy in terms of identifying what your development teams are using. It's much easier to look at a Conan artifact versus or a Maven artifact or an NPM a package JSON or something like that to identify what you're using versus trying to identify or fingerprint, jars or libraries that are on your environment because people are literally just copying files across, right? Liran, do you see from a security point of view, what are the additional gotchas do you think that exist really from an identification point of view, one easier than the other? Do you see much of this in the JavaScript space as well?
Yeah, there's like an interesting case which I think it started back with Dino. So Dino is like an alternative server-side JavaScript runtime that came kind of like into the field of the Node.js side of things, like it's compared to that. And when they started off, they had taken that decision to like not use a package manifest. So JavaScript developers would be very aware of like package JSON as a file that describes their dependencies and some other metadata or, functionalities across the project. And Dino decided not to do that. And so the way that you would use third-party libraries with Dino on a project would be to, go to like the top of the file and kind of like, import, like you would import, back when a bunch of us were kids, like 90s or so, and you would import, script source or something and add some JavaScript there. So you would do the same for, in a Dino ecosystem or, the language space itself. And that proved to be like, not to be opinionated here, but it's like very dangerous, in a sense as well, right? Like there's no package management. You literally you have like no way to track those unless you like go through like a static analysis of the file and try to locate all of those. Who says you use an HTTPS versus HTTP? Like, I don't know, maybe there's a typo or you just copied, the wrong link and you use that instead. Go, I think, has a similar convention in one of its, package management uses, which is kind of also like doing that. And then what happens then there's like different supply chain security aspects, like what happens when the maintainer just goes, changes the repository, right? Or something like that. On GitHub, there are different dangerous issues around like GitHub repository jacking, which you could like, there's some evidence and some researchers were able to like take over some repositories who changed their names, just renamed the project, and then they took the old one. So imagine you have some, very old, Go code base, which wasn't touched for a while, but one of its packages actually renamed its name. So the GitHub repository. So there's like different ways you could take over some GitHub namespaces in a sense. So I think these are like the examples of the unmanaged packages in like JavaScript, specifically, and then maybe Go and some other languages too.
A couple of other things that might be worth talking about is the differences in the dependencies. So maybe even just like talking about the sheer number of dependencies that are being introduced. Maybe we refer to the heaviest object in the universe being Node modules directory. We'll talk a little bit about pinning and unpinning as well, typing perhaps, and then where languages are used by which companies and what the application is more likely to look like. Are they going to be more enterprise style applications, bigger applications or not?
Is it also worth touching on, like if we're talking about like the SBOM world, so just the fact that, the security world is also moving to a more transparent world where like things like SBOMs are going to be mandated in the US. It's probably going to be mandated in other places. And you really need to think about what you implement into your application, because once there's full transparency, anybody can see what libraries you have. And you need to make sure that whatever you're using is secure, because
one of the other big differences is really the sheer volume of numbers of dependencies that each of our ecosystems pull in. And I think one of the things that has kind of like been joked about, and maybe I can say this without trolling, we'll see, is in JavaScript, you very often get like 1 or 2 liner dependencies, right? And like sometimes what we would see as a method in some languages is actually as a dependency in JavaScript. And what this leads to is these very large dependency graphs. And of course, we've also the meme where, Node modules is the heaviest object in the universe, right? So even though we're most likely using the same volume of code in terms of numbers of lines of code, the dependency graph just gets much, much more complex. The bill of materials, essentially. Does this make it harder if there are vulnerabilities as a result, trying to identify how they're coming in, number of paths they're coming in, and also how to remediate? Is that fair, or is that...
It's a fair assessment, I think. That's definitely with more packages that you have. I think these days, maybe it's not that common to see the one-liners, but it doesn't really mean anything else. Like you'd have still shorter packages, like very purposed for one thing. And I think that kind of dependency tree bubbles up really, really high. it's kind of hard to imagine how different dependencies you have on like a hierarchy level. So one academic research that looked at NPM and PyPI a few years back was comparing the amount of nested dependencies you would have to install. And like the average NPM package install already gives you like 4 levels deep of a dependency chain. So definitely that is something to be concerned of and see how you are able to manage that. And you also mentioned like they also impact the vulnerability triaging, right? So like what happens when like your last dependency in the chain, if you imagine like a tree of nested dependencies or, one before last has a vulnerability. There's essentially a bunch of maintainers up the stream now that need to choose how they remediate that, like whether they replace that vulnerable dependency with something else. Are they able to like update to like a newer version of that dependency if it exists? What happens if it exists in like a new major version that kind of like maybe changes the version requirement scheme?
The more depth you go to, the more reliance there is on the maintainers to, as a result, consume the latest version. So if let's say 4 or 5 deep, and the deepest transitive has a vulnerability, you then require every parent in your dependency graph to consume the fixed version for you actually as a developer to be able to consume that. And I would guess it's no more important to get that visibility into your dependency graph, but it is important to understand as a developer the relationships, I guess, and there are going to be more relationship in JavaScript or Node, just because of the sheer volume of dependencies that you're putting in. It's going to be really important to understand that relationship and the number of paths, so that when you are pulling something in, first of all, to identify where you're pulling it in. And I guess actually this is a key difference as well, whereby because of the class loading situation in Java, you would typically have one version. This is part of the jar hell in Java. You would have one version of a loaded library in your kind of like class loader namespace almost. Whereas in JavaScript, of course, you don't have that model, right? So you could actually have multiple versions running as well. So to understand where a vulnerability could exist in multiple paths in that dependency graph, it actually becomes quite key as well. Right. From a C++ point of view, I guess depending on whether you're using a Conan or unmanaged, it becomes actually probably quite easy from an unmanaged point of view to be able to perform upgrades and things like that. From an unmanaged point of view, what's the levels of depth you see, Roy, in terms of what we would call a dependency graph, I guess, in the JavaScript world? How does that work more in the C++ space?
Again, it's similar but different to an extent. And it is definitely something that in some cases might be harder to trace back when it comes to like the embedded space of really understanding the flow of how things are being introduced and where they're being introduced. It really requires to understand the code very well and understand where the code is coming from and what it's doing in a lot more depth than in other cases. I'd sum it up by it's very similar but different just in the visibility of the dependency graph and what you're able to really easily see the versions and things like that.
Touched on kind of like versions there as well, and I think another core difference really is this approach of do you stay on absolute latest or do you pin more to a version? And I think we differ a little bit here in our approach as well, in kind of like more in, let's say, the Maven space, for example. When you pull in a dependency, you tend to pull it in a version. You don't really identify a range or anything like that. I know that's definitely different in the JavaScript space. You could, of course, still pin, but it's more common in JavaScript compared to Java. I'm not sure about the C++. In the JavaScript space, to choose a range. And I think there's a difference here in risk in terms of which you opt to go for. If you're pinning, you first of all know what you're building, and that won't necessarily change, but also in years to come, and I spoke with the Spring folks about this as well, and very often, Spring Initializer is a great way of actually getting starting on the latest versions of all your dependencies. Problem isn't with the people who are building that day. The problem is the people who built 2 years ago who actually haven't changed their POM XML, and they're still on those older versions. And they're actually not just security issues, but pulling in plenty of other functional issues and other things like that. So I guess JavaScript certainly benefits from the building to the latest version and getting your bug fixes and your security fixes more frequently. Any downsides to that, Liran?
I know of friends who part of their CI is essentially they update to the latest and see that nothing breaks. So I think that's less common in Java or C++. But I have friends who literally just do that to stay up to date, unrelated to anything, just like update to the latest, run their test. If nothing breaks, they pin the latest. Downsides might be, malicious actors on supply chain security stuff, right? Like they able to take over a package, a maintainer or whatever, and then they, of course, have issued new dependency versions. And that would, we've seen several cases of that. Faker on NPM, Colors, Node IPC, all of those are examples of like maintainers in different aspects, just like releasing offensive code that kind of like broke the dependency. And if you were always on the bleeding edge, like unrelated, you would be susceptible to that, whether that's like, by the way, a functional issue or a security vulnerability. So I'm not part of that camp of like always update to the latest no matter what. I think you definitely need to like take some buffer, understand what you're updating to and upgrading to, as well as managing your dependency hygiene in a safe way, which means knowing which dependency maintainers to take it from, and so on. Aside from that kind of note, when you install new packages on NPM, you usually grab the latest unless there's a specific reason to choose like a different major version. That is, of course, when you like first, introduce it to the project. And I think from there on, all of like the bot automation that happens in the ecosystem, whether through Snyk or others, is something that is helpful to keep you on the latest versions as needed.
It makes creating SBOMs and things like that touch harder because it always depends on when you build, right, is to determine what you're using at any one time. In fact, Roy, you were mentioning earlier actually the importance of SBOMs these days, right? And particularly in terms of the impact it's having on our industry and certainly the regulations, right, that being added into our industry. Tell us more about that.
Yeah, for sure. So definitely we're seeing trends, and I don't think it's new in like the cybersecurity world. It might be a bit newer here. The fact of just being transparent about what you're using, what your application is introducing. For just as an example, in the US, they're talking about mandating SBOMs for your application. So providing an open list of what your application is built out of, for the importance of transparency and understanding exactly in cases of supply chain, what am I introducing into my application? Historically speaking, from cybersecurity, but other fields, generally that tends to spread very quickly. I came from the brand protection world in cybersecurity, and we saw that very rapidly every single country was actually mandating the need for a brand protection vendor. I can definitely see that happening in this world as well, where the mandating of exactly what is in your code, what you're introducing, is going to be fairly widespread just for the sake of transparency. And we don't need to call out specific instances, but you have a lot of instances where third-party supply chain attacks at the end of the day caused a lot of harm. And you really want to understand exactly what am I introducing, know about it beforehand. And I'm sure that there's going to be a lot of red tapes, especially like with government companies and other types. What's FedRAMP compliant? What are you allowed to introduce? What are you not allowed to introduce? So it's definitely something that developers need to take into account.
Yeah. And I think even going back to something like Log4j, of course, it's the first thing that we need when we have a 0 day or something like that is an SBOM, about some artifact that kind of like is able to tell us accurately, is this in my domain? Where is it in my domain? And what do I need to do to fix this? And I think that transparency across companies as well will become very important, because we're not just creators of code, but we all consume other people's off-the-shelf software as well. It's important for us to know when we host software or when we use services, what else is being impacted by these 0 days and things like that as well. While we talk about Log4j, I can't believe no one's brought this up but me, actually. I was ready for a troll on Log4j. But when we talk about something like Log4j, one of the things that I was actually really impressed with was the speed at which the community, and maybe we were a touch lucky just in how good the maintainers of Log4j were in the speed at which they did roll out fixes, the openness that they did that through. That really did help the users of Log4j. And of course, the vast majority of those being through transitive dependencies, actually pull in fixed versions of the code bases. And one of the questions here is as well I'm going to go back to JavaScript, sorry, but with the ability to publish to JavaScript so easily, I guess it has led to a wild variety of different types of maintainers, many of which I think I saw a stat. I can't remember the exact stats. Something like, is it 60% or something like that are abandoned, these kind of stats? Maybe I may have made that up. I don't know. Maybe you can correct me.
That's fairly a good amount in terms of packages who have been deemed abandoned if that category is fitted into a release that was done less than 12 months.
So, yeah, I mean, I guess there's also going to be potential. One important thing to kind of like think about when we as organizations and we as developer organizations as well, think about when we use libraries, a real consideration of the community strength behind that, and also the maintenance that is happening to that library in case something happens. Pretty much at about time now, so I want to wrap up, and I want to kind of like ask what advice you would give to each of your ecosystems in terms of users of the ecosystems, rather, or security folks that are trying to secure, your applications working in your languages. What advice would you give, to be better at security, to be more, have more greater visibility into the security of their applications? Why don't we start with you, Liran?
I would say two things. First is just like manage your dependencies, hygiene in a more responsible way. That is, know how to choose dependencies, use things like the Snyk advisor that helps you understand like the package health, and like weave that into your, internal processes of how your developers choose dependencies. And then the other one is there are many existing package manager security controls, if so to say, such as, when you install new dependencies, do not allow them to run arbitrary commands and stuff like that. So definitely like apply all of those security controls that exist within the package managers themselves to, to the extent possible. And I think those are very first few good steps to just like, be at the next level in terms of just your readiness for a supply chain security issue.
No, great advice. And I think a lot of that actually is really great advice equally for other ecosystems as well. Roy, what would you add?
So generally speaking, I think everything within your code is important. The more we move towards a more modern approach where you utilize more like third-party vendors, third-party code, things like that, I think it really indicates the importance of looking at your code holistically. Like you can't really focus only on IP code, only on dependencies, only, different teams. Everybody needs to look at the entire code holistically and be able to understand the full context of what you're calling, where you're calling, what does it affect, what does it not affect. And there's a shift already, in my opinion, that's going on. And I think we need to continue that shift, really looking at the whole code and the whole application holistically and understanding that at the end of the day, like everything is moving to code. Everything is code, everything is application, everything can have a vulnerability in it, everything can be misconfigured. I think continuing down that path and really understanding that you need to look at it holistically is like the best advice I can give.
Big picture. No, great advice. And yeah, the other thing, I guess the thing I would add probably is, when we think about whether we're looking at individual ecosystems or greater ecosystems, just be very intentional about what you're doing. If you're pulling things in, know that you're pulling things in, recognize why you're pulling them in, and the health, like you say, Liran, about what you're pulling in. I think that's most important. And by intentional, I kind of mean make sure you have good open source strategies in the sense of recognizing how your build is likely works, in the sense of, are you pulling in latest? What is the result of maybe if you're on Java not pulling in latest, and how often do you need to make sure that you're looking at whether you should be, upgrading, whether through tooling or otherwise. So I think, being very intentional and getting that visibility into what you're using, I think is core. We hope that's been useful for folks who are interested in, I guess, some of the differences in and around the security of various ecosystems. So thanks very much for listening, and we hope to see you and hear from you again on the Secure Developer podcast. Thanks very much.
Thanks for listening to The Secure Developer. That's all we have time for today. To find additional episodes and full transcriptions, visit thesecuredeveloper.com. If you'd like to be a guest on the show or get involved in the community, find us on Twitter at @DevSecCon. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.